Here's the classic structure of the observer pattern. We have this subject, which is an abstract class. It talks to this observer, which is an interface, and we have concrete implementations of these abstractions. Now, with this design, the subject notifies the observers by calling the update method. The observers get notified, but they don't know what is changed. One way to solve this problem is by introducing a parameter like value here. In our example, this is going to be a primitive integer. In a real application, this can be a complex object with a few different fields. This is what we call a push style of communication, because the subject pushes the changes to the observers. Now, with this design, as you can see, this concrete observer, this is a real class, this is not dependent on this concrete subject. It knows absolutely nothing about it, because it receives all the data it needs in the update method. However, there is a problem with this approach. Tomorrow, we might introduce a new type of concrete observer, and that observer might need a different set of values. So we have to come back here and change the observer interface. We may have to introduce a new parameter, or we may have to change the object that is passed over here. We have to introduce new fields in that class. So this approach is not very flexible because the subject is making assumptions about these observers. It's assuming that these observers need these values when a change happens. Now, what if each observer needs a different set of values? So that is when we can use a pull style of communication. So instead of the subject pushing the changes to the observers can pull the data they need when changes occur. So each concrete observer should have a reference to a concrete subject, and it can call various methods to get the data it needs. So this is what we call a pull style of communication. With this approach, we have more flexibility because each concrete observer can get the data it needs. However, we have coupling between the concrete observer and the concrete subject. But this is not a bad type of coupling. A bad type of coupling is coupling between concrete subject and concrete observer. In our example, we don't want our data source class to be dependent on the chart or spreadsheet classes because these classes can change in the future. Also, we may introduce new types of observers in the future. We don't want to change our data source or subject class every time there is a new type of observer. So that is a bad type of coupling. In reality, there is no zero coupling in software. We always have some kind of coupling. But what matters is the direction of the coupling or the direction of the relationship. In this case, even though there is coupling between the concrete observer and the concrete subject, the direction of this coupling or relationship makes it an acceptable type of coupling. Over the next two videos, we're going to see both these approaches in code.